In this lesson, you're going to learn on how to calculate the molarity for the solution. Here we have various examples, and this is our first example. It states that calculate the molarity for each of the following solutions. A. 40 grams of sodium carbonate in 4 liters of the solution. B. 0.85 moles of HCl in 500 milliliters. C. 0.004 kilogram of potassium hydroxide in 400 centimeter cubic. Now, let us see the solution for this problem. Let us start with A. Here we are given 40 grams dissolved in 4 liters to make the solution. Now, how do we calculate the molarity for this? You have to know that molarity of the solution is equal to the number of moles of a volume. So, the molarity of a solution is equal to number of moles of a volume. We are given the mass of sodium carbonate. Now, let's change this into moles. We know that number of moles is equal to mass over molar mass. We're given mass 40 grams, but we don't have molar mass of sodium carbonate. Now, let's work out the molar mass for sodium carbonate. Sodium carbonate. In sodium carbonate, we have 2 atoms of sodium, 1 atom of carbon, and we add 3 atoms of oxygen. The relative atomic mass of sodium is 23 plus that of carbon, which is 12, plus 3 times relative atomic mass of oxygen, which is 16. Now we are going to get 46 plus 12 plus 48. When we sum these 3 values, 46, 12 plus 48, we get 106 grams per mole. This is the relative molecular mass of sodium carbonate. Now, after we have obtained the relative molecular mass of sodium carbonate, let's work out the number of moles. As we have said that it is mass given 40 grams, we divide by molar mass, which is the relative molecular mass of sodium carbonate, is obtained 106 grams per mole. Now, let's compute this. We have 40 grams over 106. The answer obtained here is equal to 0.3774 moles. After that, let's work out the molarity. Molarity, as we have said, that is equal to number of moles over volume. Now is equal to 0.3774 moles over volume. The given volume of sodium carbonate is 4 liters, so we divide by 4 liters. Now let's compute this. When you take that over 4, we get 0.094 mole per liter. So the molarity of 40 grams of sodium carbonate in 4 liters is 0.094 mole per liter. After that, let's go to our second part, which is part B. In part B, we are given 0.85 moles of hydrochloric acid dissolved in 500 milliliters. Now, let's find out the molarity for this solution. As usual, molarity is equal to the number of moles over volume. The data given in this problem, in terms of moles, we are given 0.85. Number of moles is equal to 0.85. What about volume? Volume we are given 500 milliliters. In order to get molarity, the given volume should be changed into liters. Now we are given 500 milliliters. You have to remember that 1 liter is equal to 1000 milliliters. Now let's change this. To get the number of liters in this amount of milliliters, we divide by 1000. Now will be equal to 500 over 1000. Here, what is obtained is the volume in liters. So this one gives 500 over 1000, 0.5 liters. Now we have the volume in liters. So we can work out the molarity. Now molarity, as we've said, number of moles over volume. So we have number of moles 0.85 mole over volume 0.5 liters. Here, let's compute this. We take 0.85 over 0.5. You get 1.7. Now, the molarity for given amount of HCl is equal to 1.7. So this is the molarity for the given amount of hydrochloric acid. 1.7 mole per liter. Sometimes, to express the molarity, we use capital letter M to mean the same as the one who writes mole per liter or mole per decimeter cubic. In part C, we are given 0.004 kg of potassium hydroxide dissolved to make 400 centimeter cubic. Now, what would be the molarity of this amount of potassium hydroxide in 400 centimeter cubic? Now, let's see the solution for this. As usual, our molarity is equal to number of moles over volume. Now, we are not given the number of moles, but we are given the volume, which is in centimeter cubic. So, here, the mass given is going to be converted in 2 moles, and the given volume, which is in centimeter cubic, is going to be converted in 2 liters. Let's start. The number of moles, we know that, is equal to mass over molar mass. Here, the mass given 0.004 kg, but we don't have the molar mass for potassium hydroxide. So let's work out first the molar mass for potassium hydroxide. Potassium hydroxide consists of 1 atom of potassium, we add with the 1 atom of oxygen, we add with the 1 atom of hydrogen. Now, the relative atomic mass of potassium is 39 grams per mole, and that of oxygen is 16 grams per mole, and that of hydrogen is 1. Let's add these 3 values. We have 39, 1, we get 40 plus 16, 56 grams per mole. After we've obtained the relative molecular mass, now we can calculate the number of moles. Number of moles, as we have said, that is equal to mass over molar mass. The mass given is equal to 0.004 kg, but we multiply it by 1000 so as to get the mass in a gram. Now we take this mass over the molar mass, which is the relative molecular mass of potassium hydroxide, as we obtained 56 grams per mole. Now it is 56 grams per mole. So let's compute this. We have 0.004 times 1000 over 56. We get 0. The answer obtained here is 0.07143. These are moles. So we have obtained the number of moles of potassium hydroxide present in 0.004 kilogram of itself. Now let's work out the volume. Volume given is equal to 400 centimeter cubic. Here the volume given is in centimeter cubic, so we should convert this value into liters. You have to know that 1 liter is equal to 1000 centimeter cubic. So to convert the given amount of volume in centimeter cubic into liters, we should divide the given value by 1000. Now this is equal to 400 over 1000, and the obtained value will be in liters. Here we are going to get, when you take 400 over 1000, what you get is 0.4 liters. So we have the volume 0.4 liters, and we have obtained already the number of moles, which is 0.07143 moles. Now let's finish with the molarity. Molarity, we have said that is equal to number of moles over volume. So it will be equal to the obtained number of moles, which is 0.07143 over 0.4. Now the answer will be equal to, when you take that value 0.07143 over 0.4, you get 0.17886. This is the molarity of potassium hydroxide. So the molarity of potassium hydroxide made when 0.004 kilogram of sodium is dissolved to make 400 centimeter cubic of the solution is 0.1786 mole per liter. As I have told you that we write capital letter M to represent molarity. So the one who uses capital letter M is the same as the one who writes mole per liter or mole per decimeter cubic. This is the solution for the first example. After that, we are going to see a second example. The second example states that find the volume that will dissolve 12 grams of sodium hydroxide to make the solution having the molarity of 0.25. As usual, you have to know that the molarity of the solution is equal to the number of moles over volume. In this problem, we are asked to calculate the volume while the molarity is given. So here, let's use the given mass to calculate first the number of moles. As we know, the number of moles is equal to mass over molar mass. Now, as mass is given 12 grams, so let's first find the molar mass for sodium hydroxide. The relative molecular mass for sodium hydroxide can be worked out as follows. In sodium hydroxide, we have 1 atom of sodium, 1 atom of oxygen, and 1 atom of hydrogen. When we add the relative atomic masses for each element here, we have the relative atomic mass of sodium is 23. We add for oxygen 16 grams per mole. We add for hydrogen 1 gram per mole. When we sum these, we get 23 plus 17, whereby we get 40. So it is equal to 40 grams per mole. Now, the relative molecular mass of sodium hydroxide is 40 grams per mole. After that, let's find out the number of moles. Number of moles will be equal to, we've said, mass over molar mass. So it is 12 grams given as the mass over molar mass, which is 40 grams per mole. Now let's work out 12 of 40 to get the number of moles of sodium hydroxide. We take 12 over 40. Here we obtain 0.3 moles. Now we have obtained the number of moles. As we have been given the molarity for sodium hydroxide solution made, which is 0.25, so our molarity is 0.25. This is equal to mole per liter, will be equal to the number of moles. Here is the formula states moles over volume. Number of moles obtained is 0.3. We divide by the volume, which is not known. We are looking for it. Now, how do we get our volume? Our volume now will be equal to the number of moles, which is 0.3 mole, over the molarity given, 0.25 mole per liter. So now let's divide 0.3 by 0.25. The answer here is 1.2 liters. So the volume of sodium hydroxide solution made would be 1.2 liters. After that, let's go to a third example. In a third example, we are given 10 grams of sodium hydroxide is dissolved in water to make a solution of 250 centimeter cubic. Now we are asking to calculate A, the mass concentration of this solution, B, to calculate the molar concentration of this solution. Now let's see the solution for this problem. Solution. In part A, we are asking to calculate the mass concentration. You have to know that mass concentration is equal to the mass of a given substance over volume. In this problem, we are given the mass of sodium hydroxide as 10 grams. Now mass is equal to 10 grams. What about volume? The volume given is 250 centimeter cubic. Volume 250 centimeter cubic. Let's convert this given volume from centimeter cubic into liters. You have to know that 1 liter is equal to 1000 centimeter cubic. Now, to convert the given volume, which is in centimeter cubic, into liters, we divide by 1000. So this value will be equal to 250 over 1000, and the obtained volume will be in liters. So when we divide this, you get 0.25 liters. After that, we have the volume in liters and the mass in grams. So we can work out the mass concentration. Now the mass concentration for sodium hydroxide will be equal to the given mass, which is 10 grams, of the volume, which is 0.25 liters. Here, let's compute this. When we take 10 of 0.25, 10 over 0.25, you get 40. So it will be equal to 40 grams per liter. This is the mass concentration of 10 grams of sodium hydroxide dissolved in 250 centimeter cubic. So this is the answer. After that, let's see the solution for our second part. In our second part, we are asked to calculate the molar concentration of this solution. Whenever you ask you to calculate the molar concentration, you have to put in mind that what is asked there is molarity. So here, in terms of molar concentration, we are going to find the molarity of the solution. As usual, we've said that molarity of the solution is equal to the number of moles over volume. So let's see. As we've said that molarity, which is the same as molar concentration, is equal to number of moles over volume. Now, how many moles are we given of sodium hydroxide? We are not given the number of moles. Instead, what we have is the mass. So let's convert the mass given, which is 10 grams, into number of moles. Here we know that number of moles is equal to mass over molar mass. Mass over molar mass. Mass already we are given, but what about molar mass? Molar mass for sodium hydroxide is equal to, here we have 1 atom of sodium, we add with the relative atomic mass of 1 atom of oxygen, we add with the relative atomic mass of hydrogen, which is 1 atom. Now here, the relative atomic mass of sodium, 23 gram per mole, of oxygen, 16 gram per mole, of hydrogen is 1 gram per mole. When we add these three values, this is 17 plus 23 is 40 gram per mole. Now, the relative molecular mass of sodium hydroxide is 40 gram per mole. After we've obtained the relative molecular mass, we are able now to work out the number of moles. We take that 10 gram over the molar mass, which is 40 gram per mole. When you divide 10 by 40, 10 by 40, you get 0.25. 0.25 moles. After we've obtained the number of moles, now we can work out the molar concentration. So we have obtained the number of moles and we are given already the volume, which is 250 centimeter cubic. As if you remember, in part A, we converted this value of volume from centimeter cubic into liters and we have obtained 0.25 liters. So now our molarity, which is molar concentration, the molar concentration, which is the same as molarity, will be equal to moles over volume. Number of moles, 0.25 over volume. The volume is 250 centimeter cubic, which is equal to 0.25 liters. Now, the molarity will be equal to 1 mole per liter. This is the molarity for this solution, 1 mole per liter. This is the way we do. After that, let's go to our fourth example. This is a fourth example. It states that calculate the concentration of nitric acid that will be produced when 110 milliliters of nitric acid is dissolved in 440 milliliters of water. Take the density of nitric acid to be 1.42 gram per centimeter cubic. Now, let's see the solution for this problem. In this problem, we are required to calculate the concentration of nitric acid. It is upon you to decide which kind of concentration you are going to calculate. In this problem, we are going to calculate all two kinds of concentration. Firstly, we are going to start with the mass concentration, and after that, we will use the obtained mass concentration to get the molar concentration, which is molarity. So, let's start. We have said that mass concentration is equal to the mass of the volume. Mass concentration is equal to mass of a given substance over volume. Now, let's start with the mass of nitric acid. Here, we are given nitric acid in terms of volume. So, to get the mass of nitric acid, as we are given its density, we are going to rate the ratio of mass over volume, which is the density. Now, how do we get mass? We know from the ratio of mass over volume, which is equal to the density, we can calculate mass as that mass is equal to the density times the volume. Density times the volume. Now, this will be equal to density given 1.42 gram per centimeter cubic times volume. The volume given of nitric acid is 110 milliliters. 110 milliliters. But you have to know that milliliters is equal to centimeter cubic. So 1 milliliter is equal to 1 centimeter cubic. So writing milliliters is the same as the one who writes centimeter cubic. Now let's compute this. When you take 1.42 times 110, you get 156.2. You get 156.2. This is gram. So the mass of nitric acid contained in 110 milliliters of the acid is 156.2 grams. So we've already obtained the mass. What about volume? Here, the volume of the resulting solution is due to the combination or the mixture of nitric acid and water. So we take the volume of nitric acid, which is 110 milliliter. We add with the volume of water, which is 440 milliliters. Here, when we sum these two, we get 550 milliliters. This is the volume of the resulting solution. Now, the mass concentration of nitric acid will be equal to the mass over volume, which is 156.2 gram over 550 milliliters. So when you convert 550 milliliters into liters, is the same as the one who writes 156.2 times 1000 of 550. Now I have multiplied by 1000 so as to convert 550 milliliters into liters. Now the answer obtained here will be in gram per liter. So let's compute to get the answer. We have 156.2 times 1000 over 550. We get 284. 284. This is the mass concentration, which is in gram per liter. So the mass concentration will be this value, 284 gram per liter. After we have obtained the mass concentration, you can decide to change this into molar concentration. How do we convert this? You have to know that to get molar concentration is equal to mass concentration over molar mass. So we are going to take this mass concentration over molar mass, and what will be obtained there is what we call molar concentration or molarity. Let's see. As I have told you that molar concentration, which in other times we call it molarity, is equal to number of moles over volume, or is equal to mass concentration over molar mass. So the ratio of mass concentration over molar mass is the same as the one who takes number of moles over volume. All of the two give you the molarity of the particular solution. So Here, as we have the mass concentration, we are not going to use this formula which involves finding out the number of moles. We are going directly to use the ratio of mass concentration to the molar mass. Now, the molarity, which is molar concentration, will be equal to the mass concentration, which is 284 gram per mole over the molar mass of nitric acid. What is the molar mass of nitric acid? Let's see. The molar mass of nitric acid, which is written this way. The molar mass of nitric acid, we have 1 hydrogen atom plus 1 nitrogen atom plus 3 atoms of oxygen. Here, the relative atomic mass of hydrogen is 1. We add that of nitrogen 14. We add 3 times that of oxygen, which is 16. Now we get, here we have 3 times 16, which is 48. We add 48, we add 14. 14, we add 1. We get 63. So 63 gram per mole is the relative molecular mass of nitric acid. So here, the molar mass or relative molecular mass of nitric acid will be equal to 63 gram per mole. Now, when you compute this, what do you get? Let's divide. We have 284 over 63. We get 4.5. 4.5. This is number of moles per liter, which is the molarity. Now, the molarity of nitric acid, or the molar concentration of nitric acid, will be equal to 4.5 mole per liter. I've told you before, when you're asked simply to calculate the concentration of the solution, you may decide to calculate the mass concentration or the molar concentration. So its mass concentration we have obtained 284 gram per liter. But if we have decided to calculate the molar concentration, we've obtained 4.5 mole per liter. So it is upon you to decide whether to calculate the mass concentration or molar concentration. But all in all, both the two, molar concentration and mass concentration, are known as concentration of the particular solution. After that, let's go to our fifth example, and this will be the last one. Our fifth example states that what mass of silver nitrate is to be dissolved in water to form 150 milliliters of silver nitrate solution having a molarity of 1.35. Now, let's see the solution for this problem. We are given the molarity of this silver nitrate solution. You have first of all to know how do we calculate the molarity. You have to remember that we have said molarity is equal to the number of moles over volume, or mass concentration over molar mass. As here we are given the volume, now let's use the formula of number of moles over volume. Now molarity is equal to number of moles over volume. So, what data do we have in terms of moles and volume? Here we have volume 150 milliliters and we have 1.35 mole per liter as our molarity. So we may use this volume and given molarity to work out the number of moles. After obtaining the number of moles, it is where we will get the mass which is asked here. Let's see the volume given. Number of moles, first of all, number of moles is not known, but molarity is given. Molarity is equal to 1.35. What about volume? Also volume is given. We are given 150 milliliter, which is equal to 150 over 1000 liters. As we have said that 1 liter is equal to 1000 milliliters. So to get the amount of liters in 150 milliliters, we divide by 1000. When we divide this, we get 150 over 1000, we get 0.15. This is equal to 0.15 liters. So we have this volume and the molarity, but we don't have number of moles. So to get moles is equal to, number of moles is equal to volume times the molarity. Volume times the molarity. This will be equal to, volume 0.15 liters times molarity, which is 1.35 mole per liter. This is going to give us, we have 0.15 times 1.35. Here we get 0.2025. These are the number of moles. After we've obtained the number of moles, now we are in the position of being able to calculate the mass of silver nitrate. How do we get mass? We know that number of moles is equal to mass over molar mass. So, to get mass, we are going to take the number of moles times molar mass. What about molar mass of silver nitrate? The molar mass of silver nitrate, to work out the molar mass of silver nitrate here, we have 1 atom of silver, we add with 1 atom of nitrogen, we add with 3 atoms of oxygen. Here, the relative atomic mass of silver is 180 grams per mole, that of nitrogen 14, and that of oxygen 16. Is there 3 atoms, we take 3 times 16. Now, what do we get here? Let's compute this. When we take 3 times 16, we get 48. We add with 14, we add with 108. We get 170. So the relative molecular mass of silver nitrate is 170 grams per mole. Now we have worked out the relative molecular mass of silver nitrate. So what remains here from this formula, number of moles is equal to mass over molar mass. So to get mass is equal to number of moles times molar mass. From the data obtained, the mass of silver nitrate will be equal to the number of moles obtained, which is 0.2025 times the relative molecular mass of silver nitrate times the relative molecular mass of silver nitrate, which is 170. When we compute this, what do we get? We have 170 times 0.2025. 0.2025. We get 34.425. Now, the mass of silver nitrate will be 34.425 grams. So 34.425 grams will be the mass of silver nitrate to be dissolved that will form 150 milliliter of the solution having a molarity of 1.35. After that, this is the end of my today's presentation. I hope you have enjoyed the lesson. I take this chance to thank you for attending today's session. I welcome you in the next sessions. Have a nice moment. Bye.